Alright, video lesson 4.3, sinusoidal functions as mathematical models, and this is one denotes the first day of a few that we're going to be working on this. So if you've been thinking about where in the world would you use any of this trig stuff, I'm going to give you just a few examples you could use it, and so let's just go ahead and start with Ferris wheel problem. We're really close to this Texas State Fair, so it's a kind of a good place to start. Oops. Okay, so it says, you are standing in line to ride the Texas State Ferris wheel at the State Fair of Texas. As you are waiting, you notice that while riding the Texas Star, a person's distance from the ground varies sinusoidally. All right, this tells us that we're going to have a sine or cosine curve. It says you read in your official guide to the State Fair of Texas, of course you have this handy, you read that the Texas Star has a diameter of 212 feet. That seems important, so I'm going to underline it. And you notice that it takes 82 seconds for the Ferris wheel to make one revolution. This 82 is actually going to end up being the period of the graph. As you approach the loading dock, you estimate that passengers load the car's 8 feet from the ground on a platform. It says it is finally your time to load the Ferris wheel, but once you are on, they continue to load several other cars. So this is where they're start, stop, start, stop. When the Texas Star is fully loaded and begins to continuously turn, that's when you start your stopwatch, and it takes 50 seconds to reach the top. Okay, so problem number 1 says, how high is the top of the Texas Star? Well, if you load at 8 feet and the diameter of the wheel is 212, then the very top should be the sum of these, 220 feet. And this information is going to be helpful to us when we actually write the equation and draw the graph. Okay, problem number 2 says, what time will your stopwatch read when you get back down to the bottom? Okay, to kind of explain how we answer this, I'm going to go ahead and draw a very simplified picture of the Texas Star. Alright, so imagine this. You load right here, you start, stop, start, stop, start, stop, and somewhere it starts to continuously turn, and you know from watching in line that it takes 82 seconds to make a complete revolution. Alright, so if it takes you 50 seconds to reach the top from wherever you are, we don't know if it's the going up side or the coming down side. How long, once you're at the top, would it take to get back down to the bottom? Half of that, 41 seconds. Okay, so if it's 41 seconds to go from top to bottom or from bottom to top, you know that you had to have actually started your stopwatch somewhere over here, and that's actually where the 50 seconds comes into play. So when I want to add this all up, what time will your stopwatch read? Well, it was the 50 seconds to reach to the top, then the 41 seconds, which was the half revolution, so my stopwatch should read 91 seconds when I reach the bottom. Number 3 says, how much elapsed time will it take to reach the top of the Texas Star for the second time? Well, a couple of different ways I can do this. I can think about how to adjust the process for problem number 2. I could have done, well, it took 50 seconds to reach the top the first time, and then I'm going to add a full revolution onto that. Okay, that would be 132 seconds. Don't change this into minutes, keep it in seconds. Or another thing I could have done is taken my answer on 2 and just added another 41 seconds onto it because it's another half revolution. Either way, you'd get 132 seconds. Okay, now let's graph this. Okay, I'm going to start with drawing my axes. And then we're going to label our axes, and every single time we're going to do this, we're going to make sure we know what our dependent and independent variables are. Our independent variable here is time, and it's going to be in seconds. So I'm going to write both of that down. Our dependent variable is our height off the ground, or you could think of distance from the ground, but I'm going to go ahead and use that h for height, and that was measured in feet. Okay, now let's talk about our tick marks. I know that the lowest, once I'm on the Ferris wheel, the lowest I'm going to be is 8 feet. That's where the loading platform is. The highest is 220 feet. Now let's go ahead and find out where the sinusoidal axis would be. Alright, now we know that it's going to be midway between 8 and 20, so I could take the average of those two numbers. Or you could also use what you know about The diameter being 212, you could divide that by 2 and then subtract. Either way, you are going to get 114 here. And that's important for when we're coming up with the equation. And so I'm going to go ahead and write that down. All right, now the next part, let's use what we found in problem number 2 and problem number 3 to get some points on our graph. Okay, so I know that at 91 seconds, okay, or let's just start with what they told us. At 50 seconds, I am at the top. Okay, so at 50 seconds, I am at the top. And at 91 seconds, I am at the bottom. At 132 seconds, I'm back at the top. Okay, so I'm going to switch colors here. I'm going to use a red, and I'm going to go ahead and connect these. Now, I don't have everything drawn, but I do at least have one complete cycle drawn, and I have enough information to where I could definitely fill in the blanks if I needed to. Okay, so let's go ahead and do that. Let's find out, and I just want to be clear here, we have actually all the information we need to write the equation, but the more information you have, the more clear it's going to be. Okay, so let's just be really thorough on this problem. Let's go ahead and find out what these tick marks would be in between. Now, keep in mind that the period, I already said this was 82. So if you divide this by 4, okay, you'd get 20.5. We're going to go ahead and use decimals here, and feel free to use your calculator. This is a word problem. Okay, I can find out what these tick marks are. So 70.5. This one would be 111.5. And I could keep going. I could go backwards. I could get 29.5. And I can even find that there's another low point right here at 9 seconds. Okay, so if I continue to draw my graph, I know it's going to look something like that. Okay? All right. The whole point of this graph is to make sure that you have a good visual and so that you can answer the next question, which is now let's write an equation. Okay, so pretty much on all of these it's going to be easier to write a cosine equation. So let's just go ahead and start, and I put y equals, and I need to back that up a little bit, and I need to write h equals. I'm going to go ahead and use my variables for this problem. If you used the y though, that would be fine. Okay. What was our shift up? Okay, I can see on the picture that our sinusoidal axis is at 114. So that's what our vertical shift was. Okay, plus amplitude. Okay, whoops, back. Amplitude, you know, is going to be this amount right here. And it looks like that is 106, which makes sense because if the diameter of the wheel is 212, then the amplitude should be half that, which is 106. I've already said cosine is almost always going to be easier. We saw this with the 4.1 notes. The next thing we need to do is to deal with the b value. All right, so we know that the period, back to this one, let me switch colors here. I know that the period is 82. I haven't yet said which mode we're in, and we're going to pretty much always be in radians mode here. If you're ever not sure, just assume you're in radians mode. So if we're in radians mode, then how would I find the b value? I would do 2 pi over the period, which is 82, and that would give me pi over 41. So that's my b value. So back to my equation, I would have pi over 41, and then I'm going to use a t here, and then back to the equation I have a couple of options. I don't want to use 9 because it's a low point. I want to use 50, not 91, or 132. I'm going to go ahead and use 50 because because it's the first high point that I have. So t minus 50. And just to repeat this, you could have put y here and x here. That would have been okay as well. Okay. Let's check this because we could have made a mistake. So I'm going to go to my calculator, and this is a different one than what I've used in the past. So I'm going to go into y equals. Oops, turn it on. Okay, I'm going to go into y equals. Clear anything out that I have. 114 plus 106 cosine. And remember here, you've got to be careful about your parentheses. Oops, 41. X minus 50. Okay, so don't just do Zoom 6, don't just hit graph, go to your window. Actually, first, make sure your mode is on radians. That's the default, but it might be on degrees from another problem you're working on. Okay, now let's go to our window and let's look at our graph that we made. Negative 10 seconds doesn't really make a lot of sense. Probably my x-min should be 0, but having that as negative 10 isn't going to hurt me too much. It's just going to let me see the negative time. So I'm going to leave that. Okay, it looks like my maximum time was 132. I'm going to go ahead and extend that to 150. I might have to extend it even further later. Okay, the scale, I don't typically change that. All right, negative 10, again, that would be like 10 feet under the ground. That doesn't make sense, but to see my axis, I'm going to go ahead and keep that. And then my y max should be at least 220. I'm going to go ahead and make it be 250. All right, you have options here, but this will work. Okay, so now let's look. So first thing is we need to make sure it looks somewhat like our picture, and it does. But the next thing is let's actually check points. So I'm going to hit trace, and I'm going to hit 50 and make sure that it puts me at that first peak, and it does. Then I'm still on trace, so I'm going to type 91. It's going to take me to my next low point. 132 should take me to my next high point, and that's how you can check your equation. The reason this is important is because if your equation is wrong, your answers to any problems after that are going to be wrong. So you've always got to check your equation, make sure it's correct. Okay, so now let's look at number 6. Okay, number 6 says predict your height above the ground when t equals 15 seconds. Now you've got options on this. Probably the easiest thing to be, since I'm already on the graph, is to do trace 15, enter, and that gives me my height. And if I'm rounding to 3 decimal places, which is what you should do when you're not told to do anything else, that's going to give me 19.006 feet. How else could you find this? You could go to the table. You could plug it in. So I'd probably want to change my table start to start at 15 just so I wouldn't have to scroll too much. The thing about the table is sometimes you get cut off a little bit, like when I start to see after 21, I may not have the accuracy that I want. One other thing you could do is you could hit vars, yvars function. It'll bring up y1 and you can use function notation. And what this will do is your calculator will automatically type 15 in for x into the y1 function. And that's how you can come up. This can help you if your value is off of your graph or really far away on the table. Okay, t equals 75. Let's see if we can get this by on the graph. So 75, enter. And so that's going to be 78.170, or you could just write 17. That's still accurate to 3 decimal places. And so let's just take just a moment to make sure we understand what we're doing here. They're giving us the x value, and we're predicting the y value. They're giving us the time, we're predicting the height. This would be the time on your stopwatch. This would be how high you are off the ground. And this is going to go up and come back down, come back up and go back down. All right. So 5 minutes. Now I put minutes in italics so that this would catch your eye. You need to change this to seconds. So that's going to be 300 seconds because you would multiply by 60. And if I go and try to do this on my calculator, if I'm in trace mode and I try to type in 300, might have a little bit of a problem. I hit go to, and the problem is that this number is outside of my window range. If you remember, we only went to 150 seconds. So I could definitely change this to be past 300, or we could just use what we used before, vars, yvars, enter, and then in parentheses, type in 300, and there we go, 215.060, or just 0.06 feet. Okay, so you have options there. Use what you like. Okay, number 7 says, how high were you when you started your stopwatch? So let's think about what would time be when you start your stopwatch. This catches people because they overlook the obvious. What they're asking us is, when t equals 0, what is the height? This is just, they could have asked this on number 6. So again, you can go to the table, you can do this. On this particular problem, I really like the graph because it answers the next part for me. So it gives me that I'm 32.222 feet in the air, and I can see from the picture that I'm decreasing or I'm going down. And we saw this when we very first started our picture of analyzing what's happening on the Ferris wheel. So going down. So that's going to be 32.222, go to 3 decimal places, feet, and then we need to say moving down. And only by looking at the graph can you figure out moving down. You could probably figure it out by looking at the table, but you'd have to look at the values before and after, determine if you're decreasing or increasing. It's much easier if you just look at the graph. Okay, let's look at number 8. Number 8 says, what is the value of t the second time you are 100 feet off the ground? Okay, well, I need to find where 100 feet off the ground is. Okay, looking on my original picture that I drew, I could draw in 100 feet. Okay, and I'm going to go ahead and do this in a different color. So I know 100 feet would be somewhere in here. And honestly, I'm not sure if I drew this very accurately. I don't know for sure if I hit 100 feet. Now, I did just figure out that I was 32 feet off the ground, so I guess you could note from that. But in general, you might not know. You don't really want to make assumptions based off of your drawing. But since I know that this actually was 32, it looks like the second time I was 100 feet off the ground, according to my picture, 70.5. But again, it could be around that. It's a good estimation of my answer, but it's probably not that exactly. If I go to my equation, which is already in y1, then I can find it exactly. So let's go to y equals. Let's keep our equation in y1. We need that. And let's type in y2 is 100. Oop, not 1,000, 100. Okay, so we're going to hit graph, and I can see the second intersection right here. Okay, so we know how to do intersection. You've been doing this for a while. Now, you need to make sure that you're close to the intersection that you want to find. Your calculator will always find the closest one. And so it looks like that time is 72.229, if we're rounding correctly to 3 decimal places, seconds. So I am going to write something here. I'm going to write y2 equals 100, and I'm going to write intersection. The reason is, let's say for some reason you get this wrong, but you knew how to do it. Okay, writing this will help you get partial credit. I'm not saying you're going to get a lot, but you should always be showing how you work problems on a quiz or a test. And I also want you to be able to look back at your notes and make sure that you understand how we did the problem. Okay, what is the value of t the fifth time you are 175 feet off the ground? Okay, so this is pretty similar to the one we just did. We're going to go into y equals, instead of 100, we're going to type in 175. Press graph. There's my sinusoid again, going up and down on the Ferris wheel. And it looks like I'm only going to be able to see the fourth intersection. So what I need to do is I need to go to my window and I need to change my time to make sure that I can see the next intersection. So I'm going to go ahead and type in 200. If this is not enough, we'll go back and change it. You don't want to make that number too big, because then you really won't be able to count how many intersections there are. So that looked like it was barely not enough. Okay, so I'm going to make this be 250. Okay. Okay, so you want to make sure that you're finding the correct number of intersections. 1, 2, 3, 4, 5. You want to find this intersection here. So when I do second trace 5, you want to, and I'm going to actually hit up and travel along this line. It'll be a little bit quicker. Enter, enter, enter. And it's a little past 200, I know that, so 201.502 seconds. Okay, I'm going to go ahead and write down how I did this as well. That means there's 201.502 seconds. And that's how you pretty much answer these questions. You always are going to ask to be analyze the information by drawing a picture. Then you're going to come up with your equation. Then you are going to be asked some questions. It's generally given the x, predict the y, given the y, predict the x, and some other little questions that go along with that. And we'll practice this again. So if you have questions, please write them down and ask them in class.